Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and we are on lesson 11, volume with fractional edge lengths and unit cubes. So yesterday was Saturday or Sunday, but Friday we started this lesson and we talked about the volume formula. So we're going to quickly review that. Who can tell me what the volume formula is? Cassie. Very good. Volume equals length times width times height. There's another formula I want you to know. This one is really awesome. Volume equals capital B times H. So the capital B, does anyone have an idea of what that could mean? Ethan? The base. The what of the base? The base of the shape. It's actually the area of the base. So when we find volume, we have to multiply the length times the width. Isn't the length times the width the area? So if we want to find the area of that rectangular base, we're going to multiply those two and then multiply it times the height. So sometimes questions will say, you know, what the base is, and that's really great because that means they've already done some of the math for you, okay? They've already multiplied the length times the width. Kids will get to that and a question that says the base is this big, this many units squared times the height of whatever, and the kids will go, I don't know what the other dimension is, like there's no length given, there's no width given. It's because they've already multiplied those two numbers for you. Any questions on that? We'll come to a few examples. We're just going to do a quick review right now. So we already did the opening exercise. We found out that this rectangular prism on the left had a volume of 240 cubic inches, and the one on the right had 240 cubic inches. And when you're in 6th grade, very rarely will you be asked what is the volume of the box. What they're going to say is how many 1 inch by 1 inch by 1 inch cubes will it take to fill the rectangular prism shown. Right, so they're going to change that wording to make it sound more complicated. And the volume means how many square units it would take to fill it. Okay? You with me? All right. So down here, we did example 1 together, and we calculated that it would take 1,920 half inch by 1/2 inch by 1/2 inch cubes to fill this box. All right? And again, how you do that is you take your denominator 2, you cube it, which would give you 8. You take your volume and you multiply it by 8, right, to find out how many of the 1/2 by 1/2 by 1/2 inch cubes it would take to fill it. So a lot of kids look at that and it confuses them. So I'm going to show you a different way of looking at that. So if it's a 10 unit or 10 inch long box, right, everyone can see that this dimension is 10 inches, right, it would take 10 units or 10 of those little boxes lengthwise to fill that, right, and it would take 4 of them widthwise and 6 of them high to fill that box. So if we had 1/2 inch cubes, it would take, instead of 10 to go across here, how many would it take to go across? 20. Very good. How many would it take to go this way? And how many would it take to go up? 12. On your calculators, go ahead and multiply 20 times 8 times 12. You can go grab one or borrow one over here. All right. So what did you get, Connor?
1,120.
Very good. Same answer, right? Jacob, which way do you think's easier?
The one that we just did with the 1/2 inch.
With when we double it and say 20?
Yeah.
Okay, yeah. A lot of kids can see that a lot easier because it would take, instead of 10 cubes across, it would take 20 because they're half the length, right? So a lot of kids think like, ooh, it would take double the amount, right? And they get it wrong. Well, that would mean you only split it that way, but don't forget the height and the width as well, right? So it would take 8 times as many to fill that same area. Now here's a challenge question that they don't ask you. What if they were 2 inch by 2 inch by 2 inch blocks? 2 inches wide, 2 inches tall, 2 inches long. How many would it take going across in that case? Would it take 10? No. How many would it take? What's 10 divided by 2? 5. Okay, so it would take 5 boxes across, right? If they're 2 inches wide, how many boxes would it take here? Jose's going 2 to me, but he's not saying it. So 2 inches, 4 divided by 2 would be 2 boxes, right? 6 inches divided by 2 would be 3. So we would have 5 times 2 times 3. So 5 times 6 is 30. Yeah, it would take 30 2 inch by 2 inch by 2 inch cubes to fill that same space. So the volume of that box is not going to change despite what we put in it. All right, so if we fill it with teeny tiny little cubes, the volume doesn't change, right? If we fill it with big cubes, the volume doesn't change. It's just how many we can fit in there would change, okay? So we're going to move on to the next page. Okay, on the next page we have example 2, and in this example we have a rectangular prism that has a length of 1.5, a width of 1, and a height of 3 3/4. So it says a 1/4 inch cube was used to fill the prism. How many 1/4 inch cubes will it take to fill the prism? What is the volume of the prism? And how is the number of cubes related to the volume? So first of all, we have to find the volume of this rectangular prism before we can figure out how many 1/4 by 1/4 by 1/4 inch cubes it would take to fill it. So the volume formula is volume equals length times width times height. Now we're just going to plug in these values, 1.5 times 1 times 3 3/4. And let's see. We need to just multiply now. It seems like there was something else I was going to say, but I can't remember. What I was going to say is, don't get hung up on the fact that, 1.5 I'm calling the length, right? If you called 1 the length and 1.5 the width, the world isn't going to implode, all right? They're all just being multiplied, so you're good there, okay? As long as you have something that's the length, the width, and the height, you're good. So I'm going to pause this. I'm going to show the kids how to do this on a calculator. So if you're watching this and you have a scientific calculator, that is a, let's see, T130X2S, Texas Instrument. There is a fraction button in the second column. It looks like a mixed number with variables. It has A, B over C. And that is our way of communicating with the calculator that we're typing in a fraction. So you type it in between whole numbers and between numerators and denominators, okay? You never start or end with the fraction button. All right, I'm going to pause this. I'll be right back in a sec. Okay, so when you multiply those out, you should have gotten 5 5/8, and we're talking about inches cubed for volume. Now, the question is, how many 1/4 inch cubes will it take to fill the prism? So again, you're going to take 4. In this case, 4 is our denominator, and we're going to cube that. So what is 4 times 4 times 4? And your calculator actually has a little button that'll help you with that. If you type in 4, there's an up thing that looks like this, called a caret. All right, that button will tell you, hey, this number goes up there. So 4 caret 3. That means 4 times 4 times 4, which is what, Adriana? Very good, 64. So we have to take, now this is insanity in my opinion. We have to take our answer and multiply it by 64. It's because it would take 64 1/4 by 1/4 by 1/4 inch cubes to fill a 1 inch by 1 inch by 1 inch cube, because you need 4 times as many long, 4 times as many wide, and 4 times as many tall. And when you multiply 4 times 4 times 4, you get 64. So we're going to take, okay, well, we're going to do that over here. So 5 5/8 times 64. That's going to tell us how many 1/4 by 1/4 by 1/4 inch cubes it'll take to fill this thing. You guys should have gotten what? 360, very good. If you're having trouble getting that, please raise your hand, I'll help you. All right, I'll be right over. So let me write this down. 360 cubes that are 1/4 by 1/4 by 1/4 inch are needed to fill the prism. So again, we're taking that denominator, 4, and we're cubing it. That's how we got 64. And then we're using that to multiply by our volume. So the volume of that prism is exactly the same as it was. It's just we're filling it with tiny little objects. So it's going to take a lot more of those tiny little cubes to fill it than bigger cubes, right? It'd be like filling a box with Rubik's cubes versus little Legos, right? It's going to take a lot more little Legos to fill it than it would be the Rubik's cubes. Okay, so the kids are working on exercise 1. Use the prism to answer the following question. So volume equals length times width times height. We're going to plug in our length of 5 1/3, our width of 2/3, and our height of 1 1/3. We're going to multiply those. I'll be right back. So when you multiply that out, you should have gotten 4 and 20 over 27. And then what units would we use here, everyone? Well, everyone was Kyla. Centimeters cubed. Very good. All right, so again, cubic units. In this case, centimeters. So cubic centimeters or centimeters cubed. All right, so if we had to fill this prism with cubes whose side lengths are less than 1 centimeter, what size would be best? So would we want to do it with 1/2 inch by 1/2 by 1/2 inch, 1/4, 1/3? Like, what are you thinking, Connor?
1/3, because every number we have is with a 1/3.
Very good. Nice job. So if you look right here, these are all thirds, right? Or 2/3 or whatever. So we would choose 1/3 by, oh, Smart Board doesn't like that. All right, 1/3 times 1/3 times 1/3 centimeter cubes. How many of the cubes would fit in the prism? So again, we've got to figure out, right? We would need 3 times as many long, times 3 times as many wide, times 3 times as many high. So we're going to take 3 and cube it, right? So 3 cubed, what's 3 times 3 times 3? 27, right? So we're going to take our answer, 4 and 20/27ths, and multiply it by what? By 27. Go ahead and do that. Jacob got 128, and so did everyone else, so life is good here. All right, so now we don't want to say that the volume is 128 cubic centimeters. We want to say 128 1/3 by 1/3 by 1/3 cubes would fit in it, right? So 128 cubes that are 1/3 by 1/3 by 1/3 centimeters would fill the prism. Alrighty. So part F is really just saying, like, compared to the volume, which was, you know, pretty close to 5 cubic centimeters, 4 and 20/27, pretty close to 5. We're going to need a whole lot more little cubes, right, to fill it. When we're filling it with something small, it's going to take more. When we're filling it with something bigger than 1 unit cubed, it's going to take a lot less. All right, any questions on that? Okay, so we're going to flip to the, it says lesson 14. Let me see if I can find it here. There's lots of examples in this lesson, but we don't need to do all of those. Thank you. 47, lesson 14, volume in the real world. And we're going to go back to that formula that I taught you at the beginning of class. Volume equals capital B times H. And on your math reference sheet, which we have printed on the back cover, or the front, the back of the front cover of your modules, it's given to you as capital B times H as well as length times width times height, all right? So you need to know that capital B means they've already multiplied the length and the width, okay? So that's the area of the base. So it says the area of the base of a sandbox is 9.5 square feet. The volume of the sandbox is 7 1/8 cubic feet. Determine the height of the sandbox. So what key things have they given us? What's one thing we should underline? Jackson.
The area of the base and the volume of the sandbox.
Very good. Those are the two key pieces. And what is it asking us to do, Sky? Find the what? Find the
Height.
the height. Very good. So, we're going to determine the height. So we're going to start with our formula, and then we're going to plug in what we know. Base times height. So what can we plug in for the base? So instead of writing a big capital B, we can write in what, Troy? Very good. 9 1/2 b squared times the height, which, do we know the height? No. So we got to leave that an unknown number, a variable. And then our volume we know is 7 1/8, right? So instead of V, we're going to plug in 7 1/8. Let's scroll up a little bit. Okay, so this is where a lot of kids get confused because they're not used to seeing equations with fractions. So if I gave you, don't write this one down, but if I did 9 times a number gives us 63, right? You'd go, oh, H equals what? 7, right? And you did that by dividing each side by what? 3. Not by 3. By 9, right? So 63 divided by 9 is 7. So whatever's with your variable, you take that coefficient and you divide each side by that, right? And that's going to just leave your variable and then your answer, okay? That's how we isolate the variable in that case. So we're going to do the same thing over here, but instead of whole numbers, we have a fraction. So instead of multiplying by 9 1/2, we need to do the inverse of that, which is to divide by 9 1/2. So we're essentially going to divide each side by 9 1/2. Okay, so that's going to cancel this side out. We're going to have H equals 7 1/8 divided by 9 1/2. So you guys can use your calculators to go ahead and do that. And we're going to find out what the height of that sandbox is. So when you do that division, you get the height equals 3/4 feet. All right? In this last problem here, it says the sandbox was filled with sand, but after the kids played, some of the sand spilled out. Now the sand is at a height of 1/2. Determine the volume. So volume equals base times height. The base is still going to be 9 1/2, but instead the height is now 1/2 because they dumped a bunch of sand out. Nice job, kids. So when you when you multiply that, you're going to get volume equals 4 3/4 cubic feet, or feet cubed. All right, thank you for watching Math with Mrs. Lehman. Don't forget to like and subscribe if you haven't, and don't forget to check out the state review series of questions that I'm going over. I am offering bonus points and prizes for the people who answer questions that are asked during those videos. They're pretty short, only about 10 minutes. So that'll hopefully get you ready for what's to come in about a month. But again, don't forget to like and subscribe. I hope you have a wonderful Monday. Bye.